Exercise 9G is just about getting the equation again of tangents and normals, but this time in what formally is called the Cartesian form. So when we draw our number plane and call this the y-axis and this the x-axis, and we have our equations, x squared equals 4ay, we are operating in Cartesian form with x and y variables or pronumerals. So that's the I guess the format, the Cartesian format is what you've studied for the past 5 years, and parametrics is a different way of labelling a point, and so hence it's called a parametric form. But the Cartesian form is actually what you're used to. So we're going to be getting the equation of the tangent and the normal at the point now x1, y1, not our 2at, at squared anymore. And these equations in your ordinary x and y, on your x and y Cartesian plane, these formulas are also given on the formula sheet. And if you look closely, actually, I think I will start with the normal because it is the easiest to see that it really just comes from the equation of a straight line where you're given the gradient and a point. It is, as you can see here, y minus y1, this is our point, equals m, and you may not be able to see at the moment why that is m or how that is m, x minus x1. They've done nothing to it. They've done absolutely nothing to that, substituting into that general form for getting the equation of a line, given the point and the gradient. So that is really easy to show, which is what this question, what it's saying here. Show the equation of the normal would be y minus y1 is, and that is m, x minus x1. The only thing I would need to do for you to be able to very quickly do that, show the equation of the normal is to show you why the gradient is minus 2a on x1. So it's actually, I've had to show you how to get an expression for the gradient here for the tangent. So to get back here where we were showing the equation of the tangent on the parabola is this, which to me is really unusual. I can't see anything like y minus y1 equals m times x minus x1. I cannot see that contained within that equation. However, this is actually correct. It wouldn't be on the reference sheet if it wasn't. It is the correct format, and it does actually come from y minus y1. It comes from the same basis as the normal, but it's just had a tricky little step added to it that simplified it into this format. Now, we've got our point, x1, y1. Don't have to do anything. We just have to think about the gradient and focus on the gradient. We know the parabola is in the format x squared equals 4ay. So that's where I started. X squared is 4ay. We've got our point. We need to find the gradient. We know that the gradient is the equivalent to dy dx. Now, in this format, I can't find dy dx. I have to make y the subject, which means I'll have to divide this side by 4a and divide x squared by 4a. So I get y is equal to x squared over 4a. It's now in a form that I can differentiate. I can now find my dy dx. Don't lose sight of why we're getting dy dx. We know dy dx gives us the gradient at a particular point x. So bring the two, and this is straightforward. We're going to use our shortcut. Bring the 2 to the front, subtract 1 from the index, and we don't differentiate 4a. We only differentiate things in terms of x. It says with respect to x. So we've got our 2x over 4a, the 2 and the 4 simplify. Our gradient, it's equivalent to saying the gradient of the tangent is x on 2a. That then gives me the gradient of the normal, which is its perpendicular, minus, turn that upside down, minus the reciprocal. And that's where your minus 2a over x comes from for the normal. So this one, really easy. And we do nothing more to it than sub into the formula y minus y1 equals m times x minus x1. Now, let's backtrack to the one that's not quite that simple, but all it does is requires one more step. We've got the gradient of the tangent, and it says the equation of a tangent at the point would be y minus y1 is m, which is at the point the gradient is x1. And that actually, that should actually be x1, shouldn't it? Because we're at the point x1, which is what's actually written there, x minus x1. So it's y minus y1 is, the gradient is, you sub your x value in, which is x1 over your 2a, x minus x1. Now, I looked at that and I thought, oh, okay, I've got to make it look like this one here. And this is a long way from that, but I can see that they've just taken, maybe they've got rid of the denominator of 2a, so I multiplied both sides by 2a. 2a, y minus y1 is x1 x minus x1 all squared. This is still not in the format that I want. The 2a is good, but I want y plus y1, and then currently I've got y minus y1. I don't want, in the end, I don't want any x1 squareds. So now this is like a little technique. I've gone back to my original equation and said, given that x squared is 4ay, this x1 squared would be 4ay1, subbing in x1, y1 into here. So now I've got an expression for x1 squared. I'm going to replace that. So I've done a few things all in one step. I've left my x1 x term equals, and I've gone, I've taken that to the other side, and instead of calling it x1 squared, I've called it 4ay, and there it is, 4ay1. So it's gone to the other side, it's become a plus, and from this, I can say that x1 squared, it can be replaced with 4ay1. I had a 2ay, there's my 2ay, minus 2ay1. So all I did here, x1 x equals, well, 4ay1 minus 2ay1 will just leave me with 2ay1, and I've got 2ay. from there to there. So 2ay and 2ay1, take the 2 out of both those and you finally get your y plus y1. So this is the format for, now think about what that was, the tangent at a point x1, y1 on the parabola can be written also in this format. It doesn't have any parameters at all. It's probably not a likely HSC question, but it's still worthwhile doing these questions from 9G just to consolidate your understanding about tangents, normals, points, lines, intersections, etc.